Welcome to Session 19, Area, Surface Area, Volume, and Composite Solids. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to match dimensions to units, to decompose composite solids, and to count only exposed surfaces. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. Composite geometry becomes manageable when each component is labeled. Use this visual structure. Remaining value equals original. Removed. Read every symbol and label before calculating. The first goal is to match dimensions to units. Connect it to the second goal. Decompose composite solids. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Sketch and label component shapes. State the target and preserve its units or conditions. Step 2. Choose add or subtract for each piece. Use a separate line so signs, factors, and labels remain visible. Step 3. Compute with consistent units. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Apply cost or rounding only after the physical quantity. Verification is part of the solution because it tests the answer from another direction. Signal 1 is, material is removed. Respond by remembering, subtract its volume. Name the response before calculating. Signal 2 is, a face is internal. In that case, do not count it as exposed. The form tells you which tool fits. Signal 3 is volume is requested. Remember, use cubic units. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. Water costs 1.80 per cubic meter. What does filling that pool cost? Restate what is requested before touching the choices. The first move is, sketch and label component shapes. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning, 101.80 equals 180. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Compute with the mathematical conclusion is 180. State it with any required units, interval notation, or restrictions. The final answer is 180. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Estimate with a bounding box and compare units. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. A dimension is doubled in all three directions. By what factor does rectangular minus prism volume change? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. A focused hint. Volume multiplies by 2 cubed equals 8. Use a hint to repair the setup, then finish the reasoning yourself. The accepted answer is 8. Explain why it works and name the earliest line that would reveal a likely error. The central message is to match dimensions to units. Combine that with the discipline to decompose composite solids. Finish by remembering to count only exposed surfaces. A result becomes dependable only when the method and verification are both clear. Reflection. Which faces or volumes are actually present in the final object? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.